All right. Hey, everyone. Welcome. Every day we're bombarded with data, right? Charts, graphs, statistics, you name it. And it can be tough to sort through it all and figure out what to actually trust.
Yeah, for sure.
But, luckily for us, we've got some really interesting material to work with today.
Yeah.
PDF excerpts that break down how we sample information, how we organize it to make sense of it, and, those ideas we call averages, mean, median, mode, that whole thing.
Right. Those are foundational concepts for sure.
Yeah, and our mission, our deep dive today is to pull out those essential ideas and practical insights so you can look at all that data you encounter with a bit more confidence, a bit more clarity.
And maybe a healthy dose of skepticism, too.
Oh, absolutely. Because, and I'll just give a little teaser here, you'd be surprised how easily a simple graph can be manipulated to tell a very different story.
Oh, yeah. It happens all the time. And knowing which average, like you said, mean, median, or mode is being used, that can completely change the way you interpret the data that you're looking at.
For sure. Okay, so let's jump right in. And I think the natural starting point is sampling. So how do we even get a handle on data when we're talking about huge populations?
Right. So very often when we're trying to understand data, we're dealing with a large group, what statisticians call a population.
Yeah.
One of the examples you shared talks about hotel owners wanting to understand how all the citizens in their city felt about the idea of casino gambling.
Mm-hmm.
And that entire group of residents, everybody who lives in that city, that's the population we're talking about.
Okay, so everyone we want to know about is the population. But in that case, are you going to go and ask every single person in a city what they think? I mean, that seems a little crazy.
Yeah, that would be pretty much impossible, or at least highly impractical in most cases.
Mm-hmm.
So that's where sampling comes in. You take a smaller group, a subset of that population that hopefully will accurately represent the views of the whole.
Okay, so you're taking a snapshot almost to try to understand the bigger picture.
Exactly. It's like a little slice of the pie. Now, going back to our hotel owner example, one of them had this idea to just survey people at 6 of the city's most popular nightclubs on a Saturday night.
Okay.
Sounds efficient, right? You get tons of responses, probably pretty quickly.
Yeah.
But what do you think? Are there any potential problems with that approach? Like, if they're trying to understand what all the citizens think, not just the nightclub crowd.
Well, you've got to think, right? Who is hanging out at a nightclub on a Saturday night?
Yeah.
I mean, they're probably looking for fun, a little excitement, and they might be more open to the idea of casinos, right? Just as another form of entertainment. It's very different from, say, someone who prefers a quiet evening at home or someone who's really worried about the potential downsides of gambling.
You're absolutely right.
Yeah.
That sample of nightclub goers, it's probably not going to reflect the full range of opinions across the whole city. And this gets at this concept of bias in sampling.
Okay.
The way you choose your sample can end up favoring certain people, certain perspectives, and that skews your results.
So it's like looking at a funhouse mirror, right? You're not getting the real picture.
Exactly. And it can lead to some pretty inaccurate conclusions about the whole population.
Okay, so how do we avoid that funhouse mirror effect?
Well, the ideal is to have what's called a random sample.
Okay, so what makes a sample random?
In a truly random sample, every single person, every member of that population has the same chance of being selected. It's like a lottery where everyone in the city has one ticket.
Okay, that makes sense. Everyone has a fair shot. Now, in that hotel example, the owners tossed around a few ideas for how to get their sample.
It did.
One of them was to just randomly survey people living in oceanfront condos. But the source says that's not a random sample of all city citizens. Why not? If you randomly pick some condo owners, aren't you giving everyone a chance?
Well, not quite. Think about it. Who usually lives in those fancy oceanfront condos? It's
Yeah.
probably a wealthier demographic, right?
Yeah, probably.
Their views on things like casino gambling, maybe they're thinking about tourism revenue or property values. It might be different from someone who lives inland in a different type of housing.
Yeah.
Not every resident has an equal opportunity to be in that oceanfront sample.
Right. Okay, so it's not just about picking randomly within a group. You have to make sure the group itself is representative.
Precisely.
What about another idea they had to survey, the first 200 names listed in the city's phone book?
Ah, yes, the phone book approach. The source says that's not random either.
I mean, if you have a listed number, you've got a shot, right? So what's the issue there?
Think about how phone books are organized.
Alphabetically?
Exactly, by last name. So your last name happens to start with a letter that's towards the end of the alphabet. You're out of luck. You've got no chance of being in that first 200.
Oh, right. because they're only taking the first 200, not a random 200.
Exactly. And then you've got people with unlisted numbers, people who only use cell phones. They wouldn't be in the phone book at all.
Wow, that's a good point. I didn't even think about that. So the first two ideas, not random,
Not so much.
but the third suggestion was to randomly select neighborhoods within the city and then randomly survey people within those chosen neighborhoods.
Mm-hmm.
So 2 stages of randomness. Why is that a better approach?
That's definitely getting closer to a true random sample.
Okay.
By randomly choosing neighborhoods first, you're making sure you're getting input from different parts of the city, right? You're capturing some geographic diversity, maybe some socioeconomic diversity.
Mm-hmm.
Then you randomly pick people within those neighborhoods, so you're mixing it up even more. It's all about trying to minimize bias and increase that chance of getting a sample that truly reflects the whole city.
Okay, so sampling, you've really got to be intentional about how you choose those participants.
Absolutely.
Otherwise, your conclusions might be totally off base.
Couldn't have said it better myself.
All right. So let's say we've collected our data. We've got a good sample. What's next? We've got all these numbers. How do we actually make sense of them?
Right. You need a way to organize that raw data. And one of the most basic but powerful tools is something called a frequency distribution.
Okay, frequency distribution. I've heard that term before, but can you break it down?
Absolutely. Imagine a table with 2 columns.
Okay.
The first column lists all the different values you collected, and the second column tells you how often each value appears in your data set. That's the frequency.
Okay. So like how many times each number pops up?
Exactly. And you can use this for all sorts of data. One of your sources talks about the ages at which 35 boys had their biggest growth spurt in a year.
Mm-hmm.
So imagine you have this list of 35 ages, just raw numbers, hard to see any patterns.
Yeah, just a jumble of numbers.
Exactly. But with a frequency distribution, you could list each age, maybe from youngest to oldest, in that first column.
Okay.
Then the second column, you count how many boys had their growth spurt at that specific age. So maybe 1 kid at 10, 2 kids at 11, 5 at 12, and then it peaks, let's say 9 boys at age 14.
Okay, so now instead of just a random list, you can see that most of those growth spurts happen, let's say, between 12 and 15, with 14 being the most common. So the frequency distribution basically reveals the patterns, right?
Exactly. It takes this messy data and turns it into something that tells a story.
Okay, now what if you have a ton of data, like hundreds of values, listing every single one in a frequency distribution? That table would be like a mile long.
Yeah, that's where grouped frequency distributions come in.
Okay, grouped frequency distribution. So we're grouping the data into categories or something.
Precisely. Instead of listing every single value, you create classes, intervals. Let's say you have a bunch of test scores ranging from 40 to 99. Instead of listing each individual score, you could group them into categories like 40 to 49, 50 to 59, 60 to 69, and so on.
Okay, and then you count how many scores fall into each of those ranges.
Exactly. So your source gives this example with 40 test scores, grouped like that, into those 10-point intervals. So you don't see how many students got a 75 or an 82, you see how many got scores in the 70s. And it turns out that was the most common range, with 11 students scoring in the 70s.
Okay.
So it gives you this broader picture, a sense of where those scores cluster.
Mm-hmm. So instead of getting lost in the weeds of individual scores, you see the bigger trends.
Exactly. Group frequency distributions are great for large data sets. Now, when you create these groups, you define a lower limit and an upper limit for each class.
Okay.
In our test score example, for the 70 to 79 range, 70 is the lower limit and 79 is the upper limit.
Okay.
The difference between the starting points of those classes, like 50 minus 40, that give you the class width, which is 10 in this case.
Yeah.
Ideally, all your classes should have the same width, but sometimes there could be exceptions.
All right, so you've got frequency distributions, grouped frequency distributions, all these ways of making sense of the numbers.
Right.
But sometimes a picture is worth 1,000 words, as they say, right? So the source talks about histograms and frequency polygons. What are those all about?
Yeah, those are ways to take a frequency distribution and visualize it, turn it into a graph.
Okay.
So a histogram is basically a bar graph where the bars are touching, and the height of each bar shows you how frequent the data is within that category or class.
Mm.
A frequency polygon is kind of like a line graph that connects the midpoints of those bars on the histogram.
Okay. So both give you this quick visual snapshot of how the data is spread out.
Exactly. And then there's another visualization tool, the stem and leaf plot. That sounds a little different.
Yeah, stem and leaf, that doesn't sound like your typical graph.
It's a bit of a hybrid. You're breaking down each data point into 2 parts. the stem, which is usually the first digit or digits, and the leaf, which is the last digit.
Okay, how would that work with those test scores, for example?
So let's say you have a test score of 82. The stem would be 8, the tens digit, and the leaf would be 2, the units digit. You'd list all the possible stems in a column on the left. So
Hmm.
for test scores from 40 to 99, you'd have stems 4, 5, 6, 7, 8, 9. Then for each actual test score, you put its leaf in the row next to its stem.
Okay.
So if you had multiple scores in the 80s, you'd list all their units digits next to the stem 8.
Ah, I get it. So you can still see the individual scores, but you also get this visual representation of like how many scores are in each group.
Exactly. So if you see a bunch of leaves clustered around stem 7, a lot of students scored in the 70s.
So you can see both the big picture and the details at the same time.
Precisely. It's particularly helpful with smaller data sets. Now, we've talked about organizing and visualizing data, but we can't forget that these visuals aren't always neutral.
Right. The source even quotes that line, lies, damned lies, and statistics. It's not necessarily that the numbers themselves are wrong, but the way they're presented, the way they're shown, can really skew our perception.
Absolutely. And one of the first things they highlight is how important the scale on the vertical axis is.
Oh, yeah, I've seen that before. It's amazing how you can make the same data look drastically different just by playing with the scale.
Exactly. You can make a trend look way more dramatic or way more subtle just by stretching or compressing that vertical axis.
Mm-hmm.
The source has these two graphs showing the exact same data on poverty levels in the U.S. over a few years.
Okay.
One graph has this really spread out vertical axis, making it look like poverty is just skyrocketing, while the other one has a much tighter scale, and it makes the change seem tiny, almost insignificant.
Wow, just from messing with the scale, that's kind of scary.
It really shows you how easy it is to manipulate how people interpret a graph.
So what else should we watch out for when we're looking at graphs and charts?
The source lays out 6 key questions to ask yourself, which I think is super helpful.
Okay, let's hear them.
First, does the graph have a clear title? You want to know exactly what data you're looking at.
Makes sense. What's next?
Second, are those numbers on the vertical axis clearly lined up with those tick marks?
Mm-hmm.
And have they messed with the scale in a way that could be misleading, like in that poverty example?
Yeah, check those scales. What else?
Third, are there a bunch of unnecessary visual effects that could distract you from the actual data? Fancy 3D bars, random images. Sometimes it makes you wonder if they're trying to cover up a weak trend.
Yeah, all the bells and whistles. What's
Yeah.
number 4?
Fourth, think about the horizontal axis,
Mm.
especially if it represents time. Are those time intervals equally spaced? Sometimes they'll use uneven intervals to create a misleading impression about how fast something is changing.
Okay.
And it's also worth thinking about, could the time frame itself be misleading?
Yeah, like if they only show data from a period when something was going up really fast, you might miss that overall, over a longer period, it's actually been pretty stable.
Exactly. What's the next one on the list?
Let's see, number 5.
Right, are the sizes of the bars or other visual elements scaled proportionally to the data?
Yeah.
I mean, that seems obvious, but
You'd be surprised. Sometimes they'll distort the sizes, to exaggerate differences. Like in that source, they have an example about the purchasing power of the diminishing dollar.
okay.
They change both the height and the width of the dollar bill images to make it seem like the dollar is worth way less than it actually is.
Right, because we visually, we tend to focus on area, right? So if you shrink it in both directions, it looks like a much bigger difference.
Precisely. And that can be really deceptive.
Okay, so we've got to be careful about those distorted visuals. What's the final red flag to look out for?
The last one is all about the source of the data. Where did those numbers come from?
Okay.
Was it a study of the entire population or just a sample? If it was a sample, was it random? Could there be significant differences between that sample and the whole population? And think about who's presenting the data. Do they have a particular bias, a reason to emphasize a certain trend?
Right.
Like that other example in the source, number of square feet in an average U.S. single-family home.
They use these inconsistent time intervals in those house images to make it seem like homes are getting bigger at a steady rate. But the reality is the rate of increase actually fluctuated quite a bit over the decade.
Wow. So the source of the data, who's presenting it, that context is super important.
Absolutely. It helps you judge how reliable that visual display actually is.
Okay, so we've got to be critical thinkers, right? We can't just accept graphs and charts at face value. We've got to look closely, ask questions.
Let me agree more.
Now let's move on to another big idea, the concept of the average. those measures of central tendency. I think most people, when they hear average, they think of the mean.
Right. It's what we usually call the arithmetic average.
Exactly. So you add up all the values in your data set, and then you divide by the total number of values. Pretty straightforward. The source gives that example of the highest paid TV actors. If you add up their earnings for the year and divide by, however many actors there are, you get the mean salary. Easy peasy. But what if you're dealing with data that's presented in a frequency distribution, like that example with the students and their stress levels? How do you calculate the mean in that case?
Right. So in that case, you have to account for the fact that some values occurred more often than others.
Mm-hmm.
You essentially weight each value by its frequency. So you multiply each data value, let's call it X, by its frequency, call it F. You add up all those products, X times F, for all the values, and then you divide that sum by the total number of data points, which is just the sum of all the frequencies.
Mm-hmm.
The example walks through the calculation, and they get a mean stress level of about 6.46.
Okay, so you're giving more weight to the values that showed up more frequently.
Exactly. It's a weighted average.
Now, what about the median? How is that different from the mean?
So the median is the middle value in a data set that's been arranged in order from least to greatest.
Okay.
If you have an odd number of data points, the median is just the one right smack in the middle.
Easy.
If you have an even number, you take the average of the two middle values.
Okay, that makes sense. So for the 5 exam scores, 84, 90, 98, 95, 88, you put them in order, and 90 is the one in the middle, so that's the median.
Exactly. And the source actually gives you a formula for finding the position of the median. It's n plus 1 divided by 2, where n is the total number of data points.
Okay.
So if you have 9 data points, the median is the fifth value, because 9 plus 1 is 10, divided by 2 is 5. If you have 18 data points, the median is halfway between the 9th and 10th values, because 18 plus 1 divided by 2 is 9.5.
Okay, that's a helpful shortcut. Now, the source makes this really interesting comparison between the mean and the median using those assembly worker salaries.
Right, where you've got the 5 assembly workers and then their manager, who makes a lot more money.
Yeah, the median salary was about $22,050, but the mean was way higher, like $33,700. Why is there such a big difference?
It's all because of that manager's salary, which is what we call an outlier, an extreme value. The mean is really sensitive to those outliers. They pull in their direction. But the median is just the middle value, so those outliers don't affect it as much. In that case, the median gives you a much better sense of what a typical assembly worker actually earns.
So the mean can be misleading when you have those extreme values, those outliers.
Exactly.
It's really important to know which average is being presented because they can tell very different stories.
Couldn't agree more.
Okay, now let's talk about the mode. That's another way to think about the average, right?
Right. The mode is simply the value that appears most frequently in your data set.
Okay, so the most common value.
You got it. And a data set can have one mode. It can have multiple modes, like if 2 values appear the same number of times, it's called bimodal, or it could have no mode at all if every value appears only once.
Right, the source gives those examples. The data set 7, 2, 4, 7, 8, 10, the mode is 7 because it appears twice.
Mm-hmm.
Then the set 2, 1, 4, 5, 3, there's no mode because every number appears only once.
Right.
And in 3, 3, 4, 5, 6, 6, both 3 and 6 appear twice, so it's bimodal.
Exactly.
Yeah.
So the mode is telling you what's most typical or most frequent in your data.
Okay. Now we've got one more measure of central tendency to cover the mid-range.
Ah, yes, the mid-range. It's a quick and dirty way to get a sense of the middle.
Okay. How do you calculate it?
You just take the average of the lowest and highest values in your data set. Super easy.
The source uses that example about the best countries for women. They calculate the mid-range score, which is pretty close to the actual mean score. So it can give you a rough estimate sometimes.
It can,
Yeah.
especially if your data is fairly symmetrical and you don't have any crazy outliers. But you got to be careful because it only uses those 2 extreme values, so it could be easily thrown off by an outlier.
Okay.
The last example, with those 6 exam grades, it really shows how all these different measures, the mean, median, mode, and mid-range, can give you a different idea of what's average.
Right, and they even calculate the final course grade using each of those measures, and they all come out different. One's a C, one's a B. So depending on which average you use, you could get a completely different outcome.
It really highlights that it's not enough to just know the average.
Yeah.
You have to know which average and why that particular one was chosen.
It's all about context.
Exactly.
So to wrap things up, we've talked about how important it is to get a good sample, a representative snapshot of the data.
Right.
We've looked at all these ways to organize data with frequency distributions
Yeah.
and then visualize it with histograms, frequency polygons, stem and leaf plots.
Hmm.
And we talked about how those visuals can be tricky, how they can be manipulated, and the things we need to watch out for. And finally, we dove into those different measures of central tendency: the mean, the median, the mode, and the mid-range. We learned how to calculate each one, what they tell us about the data, and when they're most useful.
So hopefully you, our listener, are now walking away with a sharper eye for data, right?
Mhm.
You're more equipped to think critically about the information you're presented with.
Whether it's a news report, a graph in a presentation, or someone just casually mentioning an average.
You can ask those key questions now. Where did the data come from? How was it collected?
I
How is
mean,
it being presented?
so you're less likely to be swayed by a misleading graph and more able to really understand the story the data is telling.
Precisely.
So as you go about your day, maybe take a moment to think about the last time you saw a graph.
Yeah,
Did you check the scales? Did you think about those 6 questions?
good idea.
And the next time you hear someone talking about an average, maybe pause and think, okay, which average are they talking about and why did they choose that one?
It's all about being an informed and engaged consumer of data.
Absolutely. Thanks for taking